Long March 2E, LM-2E. The Long March 2E, LM-2E, also known as the Chang Zheng 2E, CZ-2E, was a Chinese orbital carrier rocket from the Long March 2 LM-2 family. The Long March 2E, original designation is Long March 2B, was a three-stage carrier rocket that was designed to launch commercial communications satellites in a geosynchronous transfer orbit, GTO. Launches took place from Launch Complex 2, LC-2, also known as Launch Area 2, LA-2, at the Xichang Satellite Launch Center, XSLC. Based on the Long March 2C, LM-2C, the LM-2E incorporates and improves upon its mature technologies. This rocket features a longer body and 4 liquid-fueled rocket boosters strapped around the first stage. The Long March 2E design was first conceived in early 1987, followed by conceptual design in early 1988, and technical design began in October 1988, gradually transitioning to production. The Long March 2E's typical low Earth orbit, LEO, launch capacity was 9,500 kilograms, 20,944 pounds. With the addition of the Earth perigee kick motor, EPKM, upper stage developed by China Hushi Chemical Machinery Company, now the 6th Academy of China Aerospace Science and Industry Corporation, CASIC, its typical geostationary transfer orbit launch capacity reached 3,500 kilograms, 7,716 pounds, and the fairing has a maximum outer diameter of 4.2 meters, 13.78 feet. On July 16, 1990, the Long March 2E rocket conducted its first test flight and was successful. On October 26, 1985, the Ministry of Aerospace Industry, MASI, of the People's Republic of China announced that the Long March series of carrier rockets would enter the international market and undertake satellite launch business for domestic and foreign users. At that time, the rocket used by China to launch geosynchronous orbit satellites was the Long March 3 LM-3 carrier rocket, but the geosynchronous transfer orbit carrying capacity of the rocket was only 1,400 kilograms, 3,086 pounds, which was insufficient to undertake the launch mission of large communication satellites. In order to meet the needs of the international satellite launch market, Chang Zheng, a researcher at the 1st Academy of the Ministry of Aerospace Industry, Harbin Institute of Technology School of Aerospace, proposed a plan to bind 4 boosters around the Long March 2C rocket. The plan was supported by Wang Yongji, the chief designer of the Long March 2F, LM-2F rocket, and others, the leaders in charge at the time, and they decided to promote LM-2E rocket, which was still in the draft stage, to foreign countries. Hughes Aircraft Company of the United States became interested in this and hoped to launch satellites with this type of rocket. In January 1987, the Ministry of Aerospace Industry, the Commission of Science, Technology and Industry for National Defense, Costin, and Li Peng, the Vice Premier of the State Council, listened to reports on the development of the Long March 2 bundled rocket. However, at this time, a disagreement arose within the aerospace sector regarding whether to proceed with the Long March 2E rocket project. Opponents argued that developing a high-thrust, clustered launch vehicle was technically challenging, required enormous investment, and that defaulting on a contract would result in huge economic losses for the country. They advocated focusing on developing the Long March 3A, LM-3A launch vehicle. Supporters, on the other hand, believed that the two were not mutually exclusive. Developing the Long March 2E would significantly increase payload capacity and simultaneously address manned spaceflight issues. Furthermore, the Long March 2E could be equipped with a hydrogen-oxygen 3-stage system of the Long March 3A in the future, increasing its geostationary transfer orbit payload capacity to 5,000 kilograms, 11,023 pounds. From November 11th to 13th, 1988, the Ministry of Aeronautics and Astronautics held a technical and economic review meeting on the Long March 2 cluster rocket project in Daxing, Beijing. The meeting approved the decision to proceed with the Long March 2E rocket project. On November 1st, 1988, China Great Wall Industry Corporation, CGWIC, and Hughes Aircraft Company of the United States signed a contract in Los Angeles to launch 2 AUSAT, Optus satellites using the Long March 2E rocket. The contract required a successful test flight to be completed before June 30th, 1990. So, on December 14, 1988, the State Council Office meeting approved in principle the plan to launch OSAT using the Long March 2E rocket. At that time, Premier Li Peng stated that launching extraterrestrial satellites was a market activity and the state could not allocate special funds. If there was a shortage of funds, loans could be obtained from the Bank of China, BUC, and the China Development Bank, CDB. Ultimately, the Ministry of Aerospace Industry borrowed 450 million renminbi from the People's Bank of China to cover the research and development and launch costs of the Long March 2E rocket. In February 1989, the State Council and the Central Military Commission, CMC, officially issued a document listing the research and development of the Long March 2E rocket as a key national project. The China's Long March 2E three-stage launch vehicle, based on the Long March 2C rocket, features the following major improvements. It incorporates 4 liquid fuel boosters. The rocket body length is increased. The first stage core stage is lengthened by 4.6 meters, 13.78 feet, and the second stage by 5.2 meters, 17.06 feet. Engine performance is improved, increasing thrust and specific impulse. The second stage employs a propellant utilization system and adds a payload attitude control and orientation system, as well as a spin starting and lateral maneuvering solid rocket. A large payload fairing with a diameter of 4.2 meters, 13.78 feet, is used. The interstage section between the first and second stages is replaced with a shell section with an open exhaust hatch instead of a rod system. The attitude control system is upgraded to a numerical control scheme, and the telemetry system has increased capacity. Like other rockets in the Long March 2 series, the Long March 2E is a 2-stage rocket. When performing geostationary transfer orbit launch missions, it requires an upper stage. Currently, 3 types of upper stages are known to be compatible with the Long March 2E. Star 63F, manufactured by Theokur, used to launch Hughes HS-601 platform satellites with a GTO payload capacity of 3,140 kilograms, 6,922.5 pounds. EPCAM, developed by China Hushi Chemical Machinery Company, with a GTO payload capacity of 3,500 kilograms, 7,716 pounds, previously used to launch AsiaSat-2 and EchoStar-1 satellites. ETS, a multi-satellite upper stage with an orbit distributor, originally planned for a 12-satellite launch mission to Globalstar in 1998, but the contract was later canceled and it was never put into use. The Long March 2E made its maiden flight on July 16, 1990, and made 7 launches in total. All of the failures were caused by excessive vibration. The first Long March 2E rocket was scheduled to launch on July 9, 1990, but was postponed to July 10 due to weather conditions. It was then postponed again. On July 12, oxidizer leakage occurred at the pulse pressure sensor of the 4 boosters. During the fuel draining of the boosters, worker Wei Wenju died from poisoning. On the morning of July 16, 1990, the Long March 2E rocket was successfully launched for the first time. On March 22, 1992, at 10:40 Universal Time, coordinated during preparations for the launch of the Australian Optus B1 communications satellite, an emergency shutdown occurred, and the launch was aborted after engine ignition due to one booster engine igniter shutdown after metal contaminants caused electric arcing. Launch vehicle suffered damage and had to be replaced. On August 14th of the same year, the launch was successfully completed, sending the Optus B1 communications satellite into orbit. This was the first commercial launch of the Long March 2E rocket. To commemorate this accident, March 22nd was designated as Space Quality Day in China. The first partial failure occurred on December 21, 1992, during the launch of the original Optus B2. Wind shear caused the payload fairing to implode 45 seconds into flight, destroying the satellite. Despite the shock from the explosion and the sudden reduction in payload weight, the Long March 2E rocket automatically adjusted its attitude and continued its planned flight, delivering the remaining parts of the Optus B2 satellite into its intended orbit. Subsequent investigations by both China and the U.S. found no design or manufacturing defects that could have caused the malfunction. U.S. satellite manufacturer Hughes requested that the fairing be reinforced. However, China chose not to follow the recommendation and instead added more rivets on the fairing for the successful launch of Optus B3. The second failure occurred on January 25, 1995 during the launch of Apstar 2, when the rocket exploded 50 seconds after liftoff. Based on readings from instrumentation that it added to the satellite, Hughes concluded that wind shear had again caused the collapse of a structurally deficient fairing. However, Liu Jiayuan, the director of the China Aerospace Science and Technology Corporation, CSC, claimed that the rocket's satellite interface was at fault and threatened never to do business with Hughes again. The two sides finally agreed that the interface and the fairing would both be redesigned. The information provided by Hughes caused great political controversy in the United States, since it could be used to improve Chinese rockets and ballistic missiles. In 1998, the U.S. Congress classified satellite technology as a munition and gave control over export licenses to the State Department under International Traffic in Arms Regulations, ITAR. No export licenses to China have been approved since 1998, and an official at the United States Bureau of Industry and Security, BS, emphasized in 2016 that no U.S. origin content, regardless of significance, regardless of whether it's incorporated into a foreign-made item, can go to China. The return-to-flight payload, AsiaSat-2, had to pay a 27% premium for satellite insurance instead of the usual 17 to 20%. Although the satellite was delivered to the correct orbit, the launch was a partial failure. Excessive forces during the launch caused a misalignment of the antenna feed horns on the Ku-band transponders, reducing the satellite's coverage area. AsiaSat, Asia Satellite Telecommunications Company Limited, filed a satellite insurance claim for $58 million. After one more successful launch, December 28, 1995, at 11:50 Universal Time, coordinated the Long March 2E was retired at the end of 1995. The rocket had compatibility flaws with the American-made satellites that caused one launch failure and two partial failures in just 7 missions. The rocket was retired on December 28, 1995 in favor of the Long March 3B, LM-3B. The Long March 2E forms the basis of the Long March 2F, used to launch crewed Shenzhou missions. The booster rockets have also been used on the Long March 3B and Long March 3C, LM-3C.